Now this video offers you a training example. It invites you to verify with risk-neutral Q pricing and also via SDF-P pricing that a firm with risky yet diversifiable cash flow shocks is worth the current dividend times 1 over risk-free rate minus expected growth rate. So here's the formal setup for the dividend process and the SDF process. We assume that dividends are growing on average with a rate of G, and we assume there's the dividend shocks DBD are Brownian motion shocks. We work with a standard stochastic discount factor for the Brownian motion economy, which equals minus RDT minus lambda dBm. And now here, importantly, the expected co-movement between dividend shocks and SDF shocks is 0. That says all dividend shocks, regardless of how risky they are not systematic. So you don't get a risk premium for these shocks. Now, therefore, the task here is to derive the pricing of the dividend stream and to show it coincides with the above expression, where you basically simply discount by the risk-free rate. Now, also explain intuitively why the value of the firm is relatively high when compared to a firm whose discount rate would be the risk-free rate plus a positive risk premium. And lastly, isn't there an arbitrage opportunity out there, as the price, which I list above, is determined without accounting for a risk premium? So if you go through the exercise, you get a training on stochastic calculus, you get a training on risk-neutral versus SDF pricing, and you check yourself whether you've understood the economics behind these mathematical finance concepts.